Ladies and gentlemen, boys and girls, welcome back to the workshop. So, today we're going to talk about stepper motors in relationship to our Bridgeport CNC build, or rebuild as I'm going to put it. Ladies and gentlemen, boys and girls, it's an especially great time here at the workshop. We got some stickers. Okay, always looking forward to getting stickers from our friends from YouTube. So, I want to give a big shout out. Don't have a bunch of stickers here, but what stickers I have, they're very worthwhile. First of all, I'd like to give the biggest shout out to John Creasy and Emma Ritson for putting this YouTube Machinist Facebook group together. They're the reason why we have stickers in the first place. So, it is a fantastic idea. If you haven't checked out the Facebook YouTube user group or the YouTube Machinist group, you should check them out. Don't walk, don't stroll, run over to the computer and check it out. You're going to find a lot of great information, and more importantly, you're going to find a lot of great people. So, let's start from top to the bottom. First off, we got Active Atom Precision Machine. Okay, these two guys, Lance and Patrick, they are what I aspire to be. They have a fantastic work ethic, probably from being watchmakers. They create and design precision micro machining products and parts. They're, I guess, the West Coast's hidden secret in Yucca Valley. Lance and Patrick, two fantastic guys, always going out of their way to try to help people, always going out of their way to try to educate people on how to do things. I personally have learned quite a bit from Lance and Patrick, and more importantly, they're two great guys. You would never imagine what's going on over at Active Atom. They have precision machines, they're rebuilding, they're putting spindles together. They're I mean, you have to go check their channel out. They have a fantastic website as well. So if you just go to YouTube and punch in Active Atom or go to activeatom.com, you're going to find a great bit of information, a great bit of links, and you're going to find a lot of most excellent stuff over at Active Atom. Thanks, Lance and Patrick. Okay, our second sticker, Rustinox. Rustinox from Belgium. Who would have thought? Belgium. Pretty cool. This guy works out on a boat. He is in the harbor. He's running around doing a lot of stuff. I think his YouTube channel is most known for his shaper videos. He's got a gorgeous shaper. He's always cutting stuff, making stuff. He's working on his workshop. I love the workshop. He's made a lot of improvements to the workshop. He's got a very cool lathe as well. Rustinox, he's definitely a really good guy on YouTube. Okay, second up, my buddy Rustinox. Rustinox is from Belgium. Pretty cool. He works out there in the harbor. He works on really, really big ships. He's got a pretty cool job. Rusty, thanks. I'm telling you, I really like Rustinox's videos. He is very creative. He's got a great sense of humor. You'll see him doing stuff from making sandcastles to forging stuff on his anvil, to working on a shaper, to working on a lathe, to working on his workshop. So, I gotta say, Rustinox, you're doing some great stuff. Rustinox hasn't been on YouTube for very long. I think it's less than a year. Correct me if I'm wrong, but you just have to check out his videos, because not only is he creative and smart when it comes to machines, but he also incorporates a lot of humor into his videos, and I really like that. He's definitely cool, and he definitely has some great stuff going on. And Rustinox, I really love that shaper. I have a small shaper. I haven't got it into operation yet, but I'm definitely going to be learning from your videos on how to use my shaper. So guys, if you haven't seen Rustinox yet, I highly suggest you go to YouTube and you check him out, because he's very cool. He's a good guy. Now finally, we have Max from Swan Valley in Perth, Australia. Max, he's got a lot of machines going on, but he's got some bigger machines that are in hiding right now. So, you know, I've been watching his videos for a while now. I'm watching his lathe fix up. He's got a gearhead lathe over there. I'm not really sure what kind it is. I think it's like a 13 by 40. It's an Asian lathe, I think. But he's doing a lot of improvements to it. That is a very popular style of lathe. So if you guys have a lathe similar to that, at least check his channel out, because there's a lot of things. He just actually reworked his oiling system on the lathe, and it's going to help the longevity of his gears. And he's doing a lot of hacks and upgrades and fixing the stuff that wasn't put together properly when the lathe was new. But you definitely have to check Max out. Like I said, he's got some larger machines in hiding. I believe he's working on a brand new workshop for himself. He's building it from the ground up. And I'm telling you, Max is a great guy, very helpful. Any questions you might have, he's more than willing to help. He's got some cool stuff going on, so definitely check Max out at the Swan Valley Machine Shop from Australia. So that's pretty neat. I mean, we got a very diversified group here. We got a, you know, the west coast of United States. We got Belgium. We got Australia. I really think that this is a great thing that we get to meet people from across the world that have similar interests to us. And anybody you check out on YouTube, 99.9% of the guys are awesome guys, and they're worth not only calling you, you know, calling them your friends, because very nice people. So, thanks again for taking the time to watch this portion of the video. Guys, keep up the great work. Love you all. And let's get back to machining, and I hope you guys are making something good in your shop. So let's go back in time to the late 80s, early 90s, and have a look at what they offered. This was the Oriental Motor, and I'm sure it's a good quality motor because, in fact, it's made in Japan. So I see absolutely nothing wrong with that if that was back in the day. I believe this is like a NEMA 34 motor. This is definitely not the smallest motor that they have, but if you look at the voltage, it's 5.4 volts. A lot of people overdriven them. Most of them were driven at 12 or 18 volts even, and it picked up some speed, and they picked up some power that way. But you know, it's your typical 6-wire, I believe. Actually, no, it's a 4-wire. No, it's a 6-wire. So it's a 6-wire motor. Very, you know, fairly simple to set up. Typically, you can even figure out how to wire it without even having a manual. Although you can still, these Oriental motors, you can still get the manual for these. In my adventures, I would only use 4 to 6 wires, typically in my setups. But that being said, this is what it is, and this was your old kind of a, you know, just a typical stepper motor from back in the day. And this might have powered your small Shoreline, you know, your small MCO type lathe. This would probably be the size that they use for, you know, a tabletop unit. And nowadays, this is the more modern type of motor. Also, well, K-Ling, this is probably a Chinese motor, I would guess. This also looks like it's a 6-wire. Or maybe 7-wire. But regardless, the wiring is inconsequential right now for what we're doing. But this is your more modern. And what's nice about this motor, it has a dual shaft, or a shaft that goes through. So now if you're working on your Shoreline and you don't need to run a program, you could actually put your small hand wheel on here, and you could go ahead and still operate it with your small Shoreline hand wheel. So that's a nice feature as well. Which is pretty cool. So working on my Bridgeport, I decided at first, because some of this stuff is expensive, I decided that I was going to get this motor here. This is a NEMA 34 motor. This is made by DMM Technologies. They're out of Canada. If you do your research, you'll find that apparently the motor itself is probably made in China. and the encoder, which is the you know, the soup and nuts of everything. This is made in Canada by DMM. And part of the reason why I shied away from the Bridgeport, although the Bridgeport steppers that were on there, they had probably the same amount of power as this, but their resolution or their steps was not as delicate or fine or a high a bit of resolution that these motors have. So you are going to get a much better end result in your product, because you're going to have a finer step, a higher resolution. It's kind of like, maybe you could equate it to a 800 by 600 picture versus high def HDMI picture. The higher resolution, the better the product is going to come out, because you're going to be able to have the finer steps. It's going to be controlled in a finer manner. And you're just going to have a whole bunch of added benefits because of that. Now, there are two different types of motors, or encoders. You have open and closed, and also there's a hybrid. So open and closed, these old stepper motors are determined, or they are open. So they go about their thing. They listen to the commands from the computer, or you know, whatever, your CNC controller. They do what it's told, but in case they lose a step, or in case they get stuck, or in case there's a glitch, or something happens in the machine, they can't remember where they are. They just follow the next step. So when you have something like that, it's very possible that if let's say you have 75,000 steps, it loses one or two here and there, your part's not going to come out 100% accurately. Now, the DMMs, they're considered closed. And what that means is they provide feedback to the software that you're using. So it actually lets them know, hey, I'm not exactly where I'm supposed to be. That's put in the most simplistic terms, but that is exactly what they're made for. Now that also depends on what software you are using. So in a lot of cases, there's software that would actually keep track of it and actually compare, or there's software that doesn't compare. So if you were to use something like a Mesa engineering board, that's a closed loop, where I believe the Centroid is open loop. I'm not 100% sure about that. Don't quote me on that. I'm still learning, but I'm pretty sure that's what that means. So in that case, and I'm going to be using Centroid. In that case, I'm going to depend on this encoder to let me know, or to let the system know that it's missed a step versus the actual software it was. And that's why, if you look at the Heidenhain Bridgeports and the Heidenhain controls, they don't have encoders on their motors. They actually rely on optical scales or magnetic scales on the machine, similar to your Accurite products, similar to your Mitutoyo. So what happens is they're working to get to a certain point from point A to B, and the actual scale on the machine is letting them know that that's exactly where they are. So they don't go by anything else, but they go by the complete actuality of the state of the machine itself. So that would probably be the best situation, the best outcome, and I'm sure that's a lot of the high-end machines are like that. So getting to my situation here with the Bridgeport, my Bridgeport came with NEMA 42 size motors, and these are NEMA 34s, because again these are quite expensive. They're 750 watts, which I determined would work with my Bridgeport. I reached out to a lot of knowledgeable people on the interwebs, and they all told me that would be fine for what I was doing. And I started to make adapter plates. So I was going to make an adapter plate for the NEMA 34 to convert it to the NEMA 42. As a matter of fact, I'm going to show you one right now. Okay guys, we're back. So I had some raw material, some tool steel, and I wanted to make this. That's exactly what I'm going to make. And of course, it's not in the frame. So let me see if I can get that. That's what I wanted to make. I did not make this one, but this was something that I got with a machine that I purchased. And this is the whole idea of it. So this was the NEMA 34 ring, okay? This was the NEMA 42 ring. Or the bolt pattern, and then of course you have the shoulder, which centers, locates the actual motor spindle, which is right here. Now I was able to build this. Here's the one I made myself, and of course I was able to get it all set up so it would fit, but I ran into some trouble attaching it to the lathe. I don't have a 4-jaw chuck for the lathe I wanted to use to cut this, so I really couldn't center it. I started working on a flat plate for the lathe, just so I could go ahead and get her done, as Mr. Fenner would say, get her done. Walk the walk, talk the walk, or whatever. But I ran into, there would have been more work trying to make standoffs and such for this, so I was like, you know what? I want to get this machine working. I still have a ton of stuff to do. I have to build the actual board to hold all the electronicals, and I have to set up all the electric. You know, we're going to be running 220 volt AC servo motors, high power. I'm going to go ahead and show you the actual converters in a moment, or the drivers. We're going to still be running a 3-phase, 2-horsepower Bridgeport variable speed motor. So we have to wire all that stuff up. We still have to determine whether we want to control the motor speed pneumatically, because it was controlled pneumatically, so we might have to work on some solenoids. And I'm like, all this stuff is really adding up, and I really want to get this project at least running. And I figured like this: if I can at least get one of these Bridgeports working, then I could go ahead and use it to make all the rest of the parts for the other Bridgeports that I have. So that's what I determined I should do. So I reached out to the guys at DMM and I asked them to rush me out 3 of their NEMA 42 servo motors. So very kindly they did it. I told them that you know, this is what I really liked. I like their product. I've heard a lot about it. There's a lot of guys that are out there doing it. So they were very accommodating. They helped me out. They hooked me up, and we're going to get some real-time knowledge of how all this stuff works. And this is part of my CNC build, my Bridgeport CNC build. And you're going to see me go through this. We're going to hook these motors up. We're going to get them all set up on the bench next. So the next step would be to set all the electronics, or at least all the basic electronics, the actual drivers, the actual 220. We need to set up the control board, which is a Centroid control board. We're going to need to set up the power supply for that, because it's a separate power supply. Then we're going to need to set up some relays, because we're going to have we're going to be able to turn on and off our mist. We're going to be able to turn on and off our flood cooling. We're going to be able to control our automatic oiler for the machine. So this is going to be like the full boat package here. We got a lot of stuff going on, and you could probably tell that I'm really excited over it. So without further ado, I just want to bring this one back in the picture one last time. This was our old school NEMA 23 motor, Oriental, made in Japan. Good motor. And this was the motor I was going to use, so you can kind of get a size difference. But wait till you get a load of this guy. Okay, so I had to actually pan out to get this box in the frame. Now, I'm not an unboxing guy on my videos, and you can see that I already took this out of the box it came in. I already cut all the tape. So let's have a look and see what this NEMA 42 motor looks like. Guys, this thing is a monster. Look at this thing. This thing probably weighs 15-20 pounds. look at the size of that motor. This is a 1.3 kW motor. Runs at 220 volts, single phase or three phase. It has 23.3 Newton meters of torque. And Newton meters per torque, if you convert that to pounds per inch, you're looking at 206 pounds per inch. This thing could twist the arm off a donkey, let me tell you. So there's going to be no holding my Bridgeport back after this. We got three of them. We got one for the X, one for the Y, and one for the Z. So now just a little, let me roll the video back a little bit. Another part of the problem was with this motor plate that I built. You can see the size difference there. Let me see if I can focus this a little better. So another problem with the motor plate that I built, which would have been fine, of course I had to open up this hole to fit that flange, which we discussed. But I also think that now that I had an adapter plate on it, I was going to have to also make an adapter for the shaft. So not that we can't make a keyway, not that we can't make an adapter for the shaft, but it was just, it would have been too much. So we're going to go ahead and save these motors. I have a feeling that my Heidenhain Bridgeport might have NEMA 34s on it, and if that's not the case, I do down the road, I want to create or build a actually retrofit one of my lathes to be CNC, one of my Delta Rockwell 11s, so we could use this motor for that. We'll have plenty of uses. We're not going to let them go to waste. I did buy a couple of them probably 6 months ago, different sizes. I just wanted to see how they, you know, how they operated and what they were. But anyway, this is the motor. You're looking at it for the first time. I'm looking at it. And one thing else you'll see here is you're looking at the bench being clean for the first time. That's the first time I'm seeing this bench being clean. So you know we're serious. So mounting holes are good. They're perfect. We don't have to do anything with the mounting holes. The shaft, the keyway is good, so we'll be able to slide this on. And we also have the threads inside, so we can go ahead and hook up our actual analog indicators. The Bridgeport came with kind of like, I'm not going to say they're travadials, but they're analog readouts that tell you, I think, how many 10,000ths of an inch you traveled. Might hook them back up. Maybe, maybe not, but it's there, all set to go, no problem. I am going to go ahead now and show you the actual the pulley that fits on this. Okay guys, here's my big collection of pulleys. And actually there's more pulleys in the other room, but we'll concentrate on this for now. This was my Y-axis pulley, and you can tell in here or not. It's impossible to tell there, but here I can show you this. This is the actual. There's a taper. So they call it a taper lock. So what you do is you put this on your shaft, and it's got the keyway like we need. And then what you do is you take two grub screws, they're pointed grub screws, and you tighten them in, and they actually force this deeper in this this tapered housing, and that's what locks the pulley to the shaft, which was really neat. I come to the understanding down the road a little bit that I think Dodge trucks use the same system. But there it fits on here, as a matter of fact. I think this is the proper one. I was able to find some of these on eBay, so I picked a couple up cheap just to see what was going on there. But that's how it works. It kind of slides on that pulley. Forgive me, I have like 3 thumbs here today. got a 5mm. So I'll have plenty of room. I can set this on the shaft like that. Tighten down the 2 grub screws, and there you go. You have it. So this is a no muss, no fuss. I'm be happy about that. I would like to get this machine actually at least fired up sometime next week. I still have to do all the limit switches, homing switches. There's a ton of work, and you know, on the Shoreline lathe and the Shoreline mill, and actually even on the X-Carve. The X-Carve was belt driven, and the little 3D printer is belt driven. And if you crash that machine, okay, no harm, no foul. You might ruin your part, but it's not going to damage anything. This thing, with the 200 pounds per inch, or 250 pounds per inch, whatever it is, there's so much force there, something's going to break, and that's just not going to work for me. So there you have it. There's the motor. Let me go ahead and grab one of the motor drivers and show you that. Okay, guys, here it is. Here's the Dyne 4 AC servo drive. Now this can be run either 110 or 220, or you know, whatever your house voltage is. You can run it 110 or 220, depending on how you wire it. I'm going to run it 220 because I want to get as much power as I can out of this beast. This is a 210 volt servo. There's no way I'm going to put 100 volts in it. What's great about this is you don't have to do any kind of transformers. You know, I see people building these transformers, these toroidal transformers. It's a kit. You got to put it together, or they got these big, huge, heavy, you know, old iron transformers, and they're wiring a whole bunch of I don't know, capacitors up to them and whatever, so to smooth the voltage out. I didn't want to do any of that. I just want to plug this thing in. So here we go, 220 volts in. You have a control. I think this is your control input. You have feedback input. You got a bunch of stuff. They send you all the wires. They all have plugs on the end. You plug the things in to here. You plug them in and you're done. It's just, it takes all the hassle out of it. You can see the nice, I mean, we're talking, this is like industrial, commercial grade stuff. There's no playing around here. You just plug it in and you go. Even with the other ones, the smaller ones, they don't have those same cables, but they're just Molex, Austin Powers, moly, you know, they just have the Molex connectors, and it's a done deal. You plug them in, you're good. You don't have to be, you know, Dexter's Laboratory here at that stuff. I can't do that. I mean, I can, but I don't have the time. It's just not worth it. So we got 3 of these. I'm going to go ahead and show you one last thing in this video, and that's going to be the actual Centroid Acorn. Guys, I am so excited. You're going to absolutely love this build. So here you have it. You got your servo motor. You got your driver. You got your Acorn Centroid CNC board. This plugs to your PC with a shielded Ethernet cable. So we're talking, there's no latency. It's instantaneous. It's not USB. It's right where it needs to be. Now, just to kind of lay out the items a little bit better, this is the 5 volt power supply. This powers the Acorn board. Acorn board. Plug it right in to this port here, and you have, I think, you have 8 relays, okay? Now, better off. So instead of wiring all this stuff up, doing one of those LPT to breakout boards and wiring all the individual pins, here you have a converter. This is from CNC for PC. This guy right here plugs right in, okay? Let me get this in frame. This plugs right into your well, it's supposed to plug right. Oh, I gotta take these nuts off. This plugs right in over here, okay? Now, you can use another Ethernet cable to plug into this board. This is also CNC for PC, okay? Now, this has pins on it, and this kind of drops right onto your Acorn. Now you're not doing any wiring whatsoever. Everything's done for you. It can't be any easier than that. So, follow along with me. next couple weeks we're going to have a lot of progress on this. This should be absolutely fantastic. We'll be able to do whatever we need. 4-axis. Put a rotary table on here if you like. We should be good to go. So that's it. Now before I let you guys go, I just want to give you a shout out. I want to show you my my setup for my YouTube creator channel stickers that I've been getting some. I gotta apologize. I got a bunch of stickers a while back. I never put them up, and I'm gonna go ahead and show you all my stickers right now. And I've discussed, I've actually discussed the stickers I just received at the beginning of this video, but I'm just gonna go along real quick and just show you the rest of them.